Introduction. Transpiration is the process where plants lose water through tiny pores in their leaves called stomata. As water evaporates, it helps pull more water and nutrients from the soil up through the plant. The rate of transpiration is influenced by factors like temperature, humidity, wind, and the plant structure, such as leaf size and stomata. This process not only helps move water and nutrients, but also cools the plant and keeps it firm and healthy. Transpiration is important for plants' growth and survival, helping plants adapt to their environment.
Next, I will talk about the significance of water movement. The movement of water during transpiration plays a critical role in plant health and function. So here are the key points highlighting its significance. The number one is as water transport and nutrient movement. As water moves from the roots through the stem and exits the leaf during transpiration, it helps transport essential nutrients and minerals from the soil to the plant tissue. This process supports growth and cellular function. The second significance is cooling effect. Transpiration helps regulating plant temperature by releasing water vapor. The process of evaporation from leaf stomata removes heat, effectively cooling the plant, which is essential for preventing heat stress and maintaining metabolic function. For the third significance of water movement is to maintain water balance. Transpiration creates a negative pressure in the plant, pulling water up from the roots. This maintains a continuous flow of water from the soil through the plant, ensuring that it doesn't dry out and helping to stabilize the plant internal water balance. For the fourth significance is to regulating gas exchange. As water exits the plant through the stomata, it creates a vacuum effect that helps regulate the opening and closing of stomata. This allows to effective gas exchange, such as the intake of carbon dioxide for the photosynthesis. And the last significance of water movement is to driving the water cycle. Transpiration contributes to the large water cycle, releasing water vapor into the atmosphere, which later condense and return as precipitate, influencing weather pattern and local climates.
Today, I'm going to explain the various factors that affecting transpiration rate. As you may know, transpiration is the process which water will vapor or lost from plant leaf, mainly through the stomata. So let's dive into the three key areas, which is environmental conditions, plant morphology, and also physical adaptation. Firstly, environmental conditions play a significant role, which is light intensity will affect transpiration by influencing the opening of stomata during the day. So, when during the day, higher light intensity will cause the stomata to open, allowing more water to escape. Next, we have temperature. Temperature is another critical factor. Why? Because high temperature increases the evaporation of water from the leaf surface, so they will speeding up the transpiration. Next, we have wind speed. Wind speed will impact the boundary layer of air around the leaf. So faster winds will remove humid air near the stomata, and they will maintaining a high diffusion and gradient, and also increasing the adaptation. So lastly, we have soil water ability influence this process. So if the soil is dry, the plant will close their stomata to conserve water so that they will be reducing stress. Now, let's talk about plant morphology, or how the structure of plant will affect transpiration. So the size and shape of leaf are important. Like smaller leaf or needle-like shapes, such as those in pine trees, reduce the surface area of water loss. So next, the thickness of the cuticle. The waxy layer on leaves also play a role. Plants like succulent have thick cuticles that acts as a barrier against evaporation. So lastly, we have another factor, which is stomata density and also placement. Some plants like xerophytes have fewer stomata that located under the underside of the leaf to reduce water loss. Finally, plants have developed amazing physiological adaptation to cope with different environments. Firstly, stomata regulation will allow plants to close their stomata during times of water stress to conserve moisture. Next, some plants like cacti use crystallizing acid metabolism, or we call them as CAM photosynthesis, which allows them to open their stomata at night to minimize water loss during daytime hours. Furthermore, deep root systems in plants like Prosopis juliflora help them access water stored deep underground. So lastly, in extreme conditions, some plants may shed their leaves, and this process called leaf abscission to minimize transpiration during dry seasons.
So now I will talk about the importance of transpiration in nutrient uptake aspect. Transpiration plays a crucial role in nutrient uptake by plants in several ways. So here are the key points that highlighting its importance. The first important is the creation of water flow. Transpiration generates a continuous flow of water from the roots to the leaf. This process creates a negative pressure that pulls water, along with dissolved nutrient and mineral from the soil, outside the plant's vascular system, that is a xylem. Without transpiration, this upward movement of water and nutrient will not occur effectively. The second important is the nutrient transport. As water moves through the plant, it carries essential nutrients from the soil, such as nitrogen, potassium, calcium, magnesium, and phosphorus, to various parts of the plant. These nutrients are vital for plant growth and development, playing roles in processes such as photosynthesis, enzyme function, and cell division. The third importance of transpiration is as to maintain root pressure. Transpiration helps maintain root pressure by pulling water into the roots from the soil, allowing the plant to absorb more water and nutrients from the surrounding soil. This pressure helps ensure that nutrients are actively transported into plants, even against gravity. And the last transpiration is the regulating of soil nutrient concentration. Transpiration helps regulate the concentration of nutrient in the soil. When plants lose water through the transpiration, the soil water is drawn up, which maintains a dynamic balance in nutrient available in the root zone. This helps optimize nutrient absorption.
Another important of transpiration is cooling mechanism. First is regulation of plant temperature. Transpiration cools the plant by releasing water vapor into the air. As water evaporates from the leaf surface, it absorbs heat, preventing the plant from overheating during high temperature. Second is preventing heat-induced enzyme denaturation. Excessive heat can damage enzyme critical for plant metabolism. Transpiration keeps the plant's temperature within an optimal range, ensuring enzyme function efficiently. Third is cooling the surrounding environment. Water vapor released during transpiration increases humidity and cools the air around plants. This is especially significant in densely vegetated areas, where transpiration helps create a cooler microclimate. Lastly is facilitating water and nutrient movement. Transpiration drives water movement through xylem vessel, maintaining plant hydration
that ensure efficient nutrient delivery to support metabolic activities and growth. Moreover, we can see the importance of transpiration in the overall health. First is photosynthesis support. Transpiration ensures a steady flow of water to the leaf, which is essential for photosynthesis. Water is a raw material in photosynthesis and also maintains the turgidity of guard cell, enabling stomata to open for carbon dioxide uptake. Second is supporting growth and development. Through nutrient transport, plants receive vital minerals from the soil necessary for growth, such as nitrogen, potassium, and phosphorus. Indicate transpiration ensures these nutrients reach all parts of the plant. Third is environmental adaptation. Transpiration helps plants adapt to their surroundings by regulating internal water levels. In arid environments, plants may limit transpiration to conserve water, while in humid conditions, they might increase it to expel excess moisture. Lastly is gas exchange. The stomata, which are responsible for gas exchange, also facilitate transpiration. This dual function allows plants to absorb carbon dioxide from photosynthesis while releasing oxygen into the environment. The water vapor released during this process plays an integral role in maintaining stomata function.
In conclusion, planting trees is a vital and effective strategy for greening the earth. Trees play an essential role in combating climate change, improving air quality, conserving water, and enhancing biodiversity. By planting trees, it indirectly supports sustainable agriculture and forest management, which are key to combating climate change, promoting environmental balance, and create healthier environment for future generations. By understanding and leveraging the power of transpiration, we can take small but impactful steps towards creating a greener, more sustainable future for generations to come.